Hello students, see this one is the next month. You know that according to question what we have ABCD is a trapezium, and you know that two lines are here parallel. Which lines are parallel? AB and CD. So these two lines are parallel where E point, this point is the midpoint. Okay, we have to show the line which is passing through point E and parallel to this line AB touches the point F, and F is the midpoint of BC. We have to show this, means we have to show this F point is the midpoint of BC. So you know that by converse midpoint theorem, if this point E is the midpoint of AD, so from triangle ADB we can say that this line, this parallel line with AB bisect the line DB, means here O is the midpoint of DB. It is the converse midpoint theorem. You know that the line which is parallel to AB and passing through midpoint of AB, that also bisect the another line, means DB. So definitely DO equals to OB. So by converse midpoint theorem we can say that O is the midpoint of DB. Okay, so now we will write it here. So now what we have? O is the midpoint of BD. So now we can say that as O is the midpoint of DB, so from triangle DCB, F is also the midpoint of BC. Why? Because AB is parallel to DC. Some time ago we had AB is parallel to EF. So definitely EF also parallel to DC. So that's why we can say that DC is parallel to EF. So from this figure DCB, what we can say that O is the midpoint of DB and DC is parallel to OF. So F is also the midpoint of BC. So now we will write here what? We will write now AB parallel to DC, that is given here, and what we had, AB is parallel to EF. So therefore AB parallel DC parallel EF. So from this condition DC parallel EF, we can say that DC parallel OF and O is midpoint of DB. O is the midpoint of DB. Therefore, by converse midpoint theorem, from triangle DCB, what we can say that as DC parallel to OF, means DC is parallel to OF and O is the midpoint of DB. So definitely F is also the midpoint of BC. So this one proved. So I hope you can understand. Students, see, it is your 5 number question. According to question, ABCD is the figure parallelogram. and E and F here midpoint. So we have to show the line EC and the line AF trisect the line DB. Trisect means the length of this part equals to this equals to this. The ratio of these three parts is same. We have to show that the line AF and line EC trisect the diagonal DB. Means we have to show DP equals to PQ equals to QB. Let's see how to solve the math. Okay, first I will show here AECF is a parallelogram. Why parallelogram? If I can prove here the figure is parallelogram, so we can say that this line is parallel to this and this line is parallel to this. Okay, and from this parallel property we also can prove that as this one is parallel to this line and E is the midpoint, so Q is midpoint of PB. Q is the midpoint of PB, so QP equals to PB. QP equals to QB. Okay. Now same way we have what? The line, this line parallel to this. So if F is the midpoint of DC, so from there what we can say, from converse midpoint theorem DQC, from triangle DQC, what we can say that P is also the midpoint of DQ, means DP equals to PQ. So from these two conditions what we can say now, PQ equals to QB and DP equals to PQ. So ultimately DP equals to PQ equals to QB. So let's see what I am going to write. See, first we will write here AB first we will write here AB equals to CD because opposite sides are equal. So half of AB equals to half CD. Okay, so half AB means what? AE. So we can write AE, and half CD means FC. So we have now AE equals to FC, means this one equals to this one. So, and what we can say, FC is also parallel to AE as AB parallel to CD. FC is parallel to AE. This line is parallel to AE. Why? Because AB is parallel to CD. Okay, so already we have these two conditions. So from these two conditions what we can say now, therefore AECF is a parallelogram. Okay, so if this one is parallelogram, so what we can say now, we can say therefore AF parallel to CE. AF parallel to CE. So from this we can write what implies, if A is F parallel to CE, so we can write AP parallel to QE, AP parallel to QE, and PF parallel to QC, means this line is parallel to this. Now we have this condition. Okay, so from triangle APB, means APB by converse midpoint theorem, what we can write now, as E is the midpoint of AB, so and this one is parallel to this, so what we can say, Q is midpoint of PB. Within bracket you can write as E is midpoint of AB and AP parallel to PQ. Done. Now same way, what we can write now? So Q is the midpoint of PB. So what we can write now? Therefore PQ equals to QB. Okay. Now similarly, just from triangle DQC. So now write, now same way, from triangle DQC by Converse Midpoint theorem, same way, okay, Converse Midpoint theorem, what we can say now? P is midpoint of DQ. Why? Right, as F is midpoint of DC and F is midpoint of DC, and already we have PF parallel QC. So write PF parallel QC. This is the reason, that's why P is the midpoint of DQ. Therefore we can write DP equals to PQ. Now from these two conditions, PQ equals to QB and DP equals to PQ, what we can write now? This, from these two condition A and condition B, what we can write now? Therefore DP equals to PQ equals to QB. So it means the line AF and EC trisect the line DB. So our proved complete. Okay, I hope you understand this math.